Good evening, everybody. This is Mark Miller, broadcasting from the HIFLA showroom here in Chicago, Illinois. Welcome to tonight's webinar. Thanks for joining us. We have a nice presentation for you today with Jim Laux, who is a member of the Chicago Passive House Alliance and a documentarist and just an all-around interesting dude. Jim's done a lot of research around the country, actually, visiting various archives and libraries, and has been investigating the history of passive solar architecture. So he has a wealth of information to share, and a lot of this is connected with the passive house history. And so we're excited to have him talk to us tonight. If any of you are having audio issues, please type into us so that we know. But I wanted to thank our sponsors today, HIFLA, for facilitating our Passive House Alliance Chicago meetings. Certainteed, their websites are all shown on these slides, so please support the sponsors who are supporting your alliance. Intus Windows, Mitsubishi Electric, Prosoco, who's been visiting now, I believe, 4 of our different alliance chapters around the country. They're going to be doing a presentation in Boston coming up shortly, I think on August 2nd. You can check with the Alliance National Events calendar for that information and to sign up. And if you're in the Boston area, come on out. And also in November, they'll be doing a presentation on the West Coast in San Francisco, is associated with the Green Build Expo there. Ultimate Air, ERVs and HRVs, Chemlink, and Zola Windows, and newest sponsor to the Alliance, LumenCatch. And I encourage you to visit their website. They make a very interesting LED lighting system that runs off of all Cat5 wiring and connects into smart home technologies. Also a reminder for those of you who are interested in coming to the 7th Annual North American Passive House Conference in Denver at the end of September, that the early bird registration fees are going to be closing. It says July 20th here. I believe it's being extended to July 24th, so take advantage of the early bird offer. You can go to the members only area on our FAES website, and there's a special link there to get your professional member level discounts. And then I'm going to forward it over to Jim now to give us his presentation on Towards a Half Century of Passive House History.
Thank you. Well, thank you everyone for coming this evening. Thank you to those who are joining us online. Thanks to Mark and to Kat Klingenberg, who has encouraged this kind of presentation on this research into the background of Passive House. And it's Passive House 1933 to 1984, and it's not advancing. Oh, there we go. Even when they were not called by that name, and I won't get into a completely exhaustive review of the different kinds of names that have been used for these types of buildings. And you see from my scope of time here, 1933 to 1984, it's got this specific limit, and it doesn't attempt to talk about the background of the Europeans, of the Greeks and the Romans, of archaic times, of the earlier 20th century researchers in terms of building energy that may not have called their buildings solar or passive, but they were surely working in these fields and doing some very productive things. So the first section is a progenitor from 1933 to 1942, and that is George Fred Keck, the architect, based in Chicago from the mid-20s until he sadly passed away in 1980. Prolific, his archive at the State Historical Society of Wisconsin, Madison. There are over 900 project files from his many years of practice. His brother Bill, also a graduate of the University of Illinois, but 13 years younger, was an active partner with Fred Fred was what almost everybody called him, although it's sometimes you read a letter and it's addressed to George Keck, and you don't wonder, did that person not know this guy, or was it typed by an assistant who just said, well, George, I'll use the first name. George had already been in practice for a dozen years when the opportunity came to build a model house at Chicago's Century of Progress International Exposition 1933. Now, this is the depending on how you think of it, the height or the depth of the Great Depression. This is 3.5 years after the crash. Now, the planners of the fair had begun 1926-27 looking at the booming, roaring 20s economy, but by the time they got to 1933, things were rougher. But they went on with it. It was over. It even continued through 1934. Over 25 million people attended, paid 50 cents usually to attend. Well, the fair stretched out along the lake. You see, if I can move the cursor around here, here's the Adler Planetarium. Here's the Field Museum. Here's Soldier Field. And it stretched out along the lake down to past 39th Street. And if you proceed imaginatively walking, you go past the big exhibit buildings, which are some of them 150, 180,000 square feet, with many, many small exhibitors. Sweden had built quite an interesting modernist building, but as you stretch out past the two lagoons and head south, past the Hall of Science, past the exhibits of the states, you go down a midway section. This was part of the exposition, the fair type of thing, where you had Ripley's Believe It or Not. You had the streets of Paris with Sally Rand and her famous nude fan dance. You had the two-headed baby, which you had to pay to get in to see. And then before you got down to the big auto companies, towards the transport section of the fair, you came across this section of these small model homes, which are single-family homes built sometimes by individual builders, but more by building associations, like the Southern Cypress Association from Baton Rouge had built a cypress house as a model. The Association of Brick Builders, which was based in Chicago, built a brick house. Well, Fred Keck built the House of Tomorrow as one of these, and one of the unique features of it was that he, instead of being an exhibitor, meaning it was free when you were already in the fair, he worked out a concession where you had to pay 10 cents to get into this. Now think of the options of the fairgoers walking down the midway. There's the big GM exhibit stretching a couple hundred yards ahead. You're walking through these model homes, you poke into one or two. The very last one on the left, although in kind of a nice position, right with the lake. I mean, you see the porch sections here of these three levels. From the east edge of the porch, the lake is 50 feet away. It was quite a nice situation. So there's the ground level, there's the main living areas, the solarium, but as you saw from the earlier slide, this was a glass house. One of the features to make it a house of tomorrow in Fred's futuristic mind was to have an airplane. Again, 1933. In January, when Fred first did his first drawings for the house, there were 40,000 people in soup lines and bread lines in Chicago every day. And on a January day when he was designing this building, if you had people 4 or 5 abreast right out here at LaSalle and Hubbard, the line would have stretched to the lake. But the House of Tomorrow, you can't see it too on this picture. There's the Pierce Arrow was the car that was donated, and he had a car donated because I can't get into all the architectural features here because I'm talking about the roots of Passive House, but he wanted people to think of the future. He didn't really expect that people would, after the fair, ask him to build one of these houses. It's a duodecahedron. It means it's got 12 sides. But you see from this picture of it under construction, um, steel framed houses, I mean, they'd been around in the construction industry for decades. This particular piece wasn't that unique. He was trying to design something that would catch people's attention because he knew from the earlier applicants that they were building brick, wood. Although there were some innovative builders who were doing some interesting prefab stuff. Paul Fisher, for example. There was a steel house that would bolt together from without a frame because the rigid steel wall sections gave it the rigidity. Now, a question. So you put up a steel structure like this on the lake. You enclose it all in glass. From the 2012 perspective of Passive House, what's going to happen to that in May and June? It's going to overheat. Yeah. And it did. The house was air conditioned. Part of the pitch, there was a nice little booklet that was handed out for your 10 cents. Part of the pitch was that it was completely air conditioned, and there was clean and filtered air that was circulated through the house every half hour. So this was clean. And I mean, when you think of, again, Chicago, the Midwest, 1930s, primary fuel source, coal. Air pollution. I remember talking to my grandmother once from Evanston, talking about hanging white sheets out on the line and bringing them in an hour later, and they had soot on them. So it overheated. One of the things in designing it that they tried to compensate for is they had tried to do a triple level of protection: shades, blinds, and curtains. In a consideration of a design phase, which only lasted 3 months before he got into building, January, February, and March. At the beginning of April, he was building. The fair was opening the 27th of May. He tried to find a supplier that would do exterior blinds that he could adjust and rotate so they could let light in when he wanted to. But if you could keep this, he knew if you could, at this stage, if you could keep the sunlight from getting to the glass, you would cut down a significant portion of the heat. He couldn't find a supplier. He couldn't find a manufacturer who would do it. So these were all interior, but even with this, it overheated. The bedroom, which when you think of someone going on a tour of a home, the downstairs had the airplane, a nice workshop, a little modernist bar where you could have the drinks of tomorrow. Then the kind of an open living area, some nice furnishings, some nice Carrera glass that formed kind of a central column around an interior stairway and the utility core. But the bedroom, half the time, especially in the afternoons, they had to close off because it was so hot that it would heat up the whole rest of the main floor living area. So that was a challenge. But I've imagined it any number of times what it would have been like on a lovely July, August, September, October, summer evening to sit out on this deck. There's the lake 50 feet away. But one of the things the whole World Fair performance element was color. And they would do, every night, they would do these fabulous fountains and sparkling lights and do fireworks. And to think of sitting on that deck, even if it had been like today, was it 93 today here? Yeah, something like that. Yeah, you can imagine, or I can imagine the relief of, and the fair was open till 10 o'clock at night. The relief of 8 o'clock, 9 o'clock coming, being out on the deck, and getting that kind of enjoyment. The rumor that Bucky Fuller tried to teach Sally Rand the Dymaxion fan dance, I found no substantiation, but the Dymaxion fan dance. Bucky Fuller coined this, well, some friends, I think, helping Bucky coin this term Dymaxion, which was his um, dynamic maximum and ion. You kind of truncate those and put them together, and this was a lovely moniker Bucky used for years and years, mostly to if you can. Half the people here could probably capsulize it better than I can, but Bucky's design idea was to use great efficiency and think very innovatively. I'm not going to show it today, but in Fred's house for the 1934 fair, the Crystal House, he had Bucky's a prototype of a drivable prototype of Bucky's three-wheel car that was kind of tear-shaped for aerodynamics. And when you think of the other cars of the 1930s, this was pretty wild. Sure, a question? Yeah. Did someone live in the house in the fair? No, no one lived in the house. The only evidence I found was the president of the Southern Cypress Association and his wife lived in the house because they said they had some valuable wood carvings, cypress wood carvings, and the fair gave them permission. No one else was living there, lived in any of these model homes. So Fred had encountered this heat at the House of Tomorrow with all this glass. And the next part of the talk is going to explore how he responded to that. Now, one of the things he did was he and primarily his brother Bill got some consulting help at the Adler Planetarium. You remember, just at the north edge of the fair, and they set up some models where they could adjust a light as if it were the sun at a certain angle, June 21st. The two solstices and the two equinoxes, and these drawings, look at that lovely graph paper in the background, kind of for those of you who may have started working in architecture at the drawing phase instead of the CAD phase. But this is undated from the Keck archive, but in some ways it's the most primitive drawing, and there are a few notes on the page I didn't include which reflect that they also found out that right at Fred Keck, his wife, and Bill Keck lived in Hyde Park. They found that just a 10-minute walk from where they had an apartment building was a pyroheliometer run by the National Weather Service that had been recording hourly data since the early 1920s. So they could give them very reliable data, not just calculations, but data on what the daylight was, what the sunlight was, and averaged over many years and many seasons. So I'm not getting a curve. Oh, there it is. So this is December 21st, right? And June 21st, that's the solstice. And the idea is you design the overhang of the building so that it'll keep that light. June 21st, you want to keep out. You want to shade. It's hot. It's in the summer. You don't need the sunlight. But the lower line, the December 21st, that you want to have the maximum penetration of light. So this was the map that Fred pursued. Now he did other things too. He designed different types of radiant heating with massive floors, sometimes clay tile. He built some flat roof buildings where he floated an inch of water in order to have evaporative cooling in the summer. I think he first tried that in central Missouri. So by 1940, he designed for Howard Todd Sloan, an old friend of his, this house in Glenview. And you see how these unusual eaves. Some people have speculated that Fred Keck was trying to make like a real dramatic architectural statement. That's why he made these eaves so strong and dynamic. And on the right, you see inside a picture of how the clear story light falls. And when the house opened, September 21st, this was a headline in the real estate section of the Chicago Sunday Tribune. And this is apparently where the moniker, the name Solar House was first used, and certainly when you look at American architecture after 1940, this is where it became common and popularized, and then it blossomed into it was quite a mass market, mass publication phenomenon. People talked about solar homes. People built solar homes, including Fred continued to. Now, I'm not expecting you to read these specifications here. I put this tiny piece of the specifications for the Sloan House, page 3, and highlighted this one section. In the original typed form, and these were individually typed, this is nothing mimeographed, it's typed in carbon copies. You see that 1 inch of insulation has been penciled in to change to 4. Now, when I've looked at houses Fred was designing in this era of the late 30s, early 40s, 1 inch, 2 inches of insulation in the ceilings were about normal. But for the solar house, he at some point, and I don't know if he did this the week before it started building or he thought about it later and penciled it in 2 months after the house was built, but he specifies 4 inches of insulation for his first home that is called the solar home. Here's the Sloan House in 2010, still in Glenview, still with that beautiful clear story. It's been updated and modified a little bit, but according to the Glenview Historical Society, it would qualify for preservation on a number of terms because one of the key parts here, it's been in the family since it was built in 1940. Now, different members of the family have lived in it, but it stayed that way. The next jump, just a year later, is the Duncan House in Flossmoor, Illinois, another suburb. He's done some refinements here. He put in a much more massive floor because he was trying to deal with the lag of having massive heat when the sun is bright and beating down in the winter, beating down and coming in through all this glass. But if you have an absorber mechanism, in other words, this massive concrete floor, and then he had pipes in it where he would run hot water for the auxiliary heating, the idea was to absorb that heat, and then it would re-radiate when the sun was down or when you needed the heat. There were short time periods. It wasn't going to last for days and days. And here's the characteristic sun angles again. This ended up being published in Architectural Forum. I'm going to get to that a little bit in another minute or two. But here are the solar angles. One of his innovations to try to ameliorate some of the heat problems was to put in these adjustable vanes. He put in 6 of them across the front of the house. And I think the idea here was that when the sun was not at that peak on June 21st, but it had started to tilt around, and it would come in under the overhang. The adjustable vanes you could adjust to block some of the light from getting into the house through the windows. A picture I took a couple of years or last year. The north side windows are quite minimal. He was thinking in terms of convection from the warm on the south end, and then having some of the heat naturally convect and rise and drift out through the north windows. Also, you have less heat loss out of the north from the solid wall instead of the glass. So here are the owners in a typical winter afternoon. Hugh and Mina Duncan in Flossmoor, Illinois. Hugh became a lifelong, and Mina too, became lifelong friends of the Kecks. He was a sociology professor, quite an interesting guy in his own right. Perfectly natural picture, not staged, not Hedrick. No, it is Hedrick Blessing. But I wondered why he was shoveling the south side of the house when the garage was on the east and the street was on the north. And okay, Hedrick Blessing, well, we have to stage this. So we want the big windows, we want nice light on Minna. But then I found a real surprise. Look at that, they were going to have a solar cookout. 2 hot dogs, 1 each. So that's another solar enigma, at least somewhat speculated about. Another thing that makes the Duncan house quite special in terms of solar history is that it had performance monitoring regarding the economic results of solar heating conducted by IIT for an entire year. And interestingly, it was funded by Libby Owens Glassford, which also provided the windows. An interesting thing. So not only, going back to 33 now in the House of Tomorrow, not only did Fred find out that it overheated in the summer, and I mean it's not such a maybe it is a logical leap, but looking back on it, it seems to kind of extend. But by October, they saw that their heating bills were extremely low. And Fred tried to talk Libby Owens Ford into, so the fair was only supposed to run a year, but they saw how successful it was. So by October, they pulled a bunch of the exhibitors and vendors and concessionaires and said, "Will you come back for another year?" Most of them said yes, so they announced we're going to extend it to 34. Well, Fred went to Libby Owens Ford Glass, which had also supplied the glass for the sheet glass for the House of Tomorrow, and said, "Listen, there's something going on here. Could you give us a little funding to have someone live in here over the winter and do some measurements?" Well, he didn't succeed in convincing them to do that or in any of his other projects, but from 1933 till 1940, well, he convinced them in 1940, late 1940, partly after the Sloan House made a splash in publicity. He got Libby Owens Ford to contribute, think of this massive sum now, $6,000. But it paid for a lot of monitoring equipment. This is Bill Knopf, a graduate student at IIT. This is the way graduate students dress today, isn't it? Suit and tie, black jacket. They wired the house. They recorded and analyzed data about solar radiation, temperature outdoors and at the floor and ceilings indoors, humidity, wind velocity, hours of daylight, weather conditions, like was it really cloudy, was it sunny, was it passing clouds, was it rainy, daily fuel use, power use, moisture accumulation in the walls and roof insulation, and heat losses on the window sash perimeters. Now, the results were mixed. Now, the date that they were recording, again, October 1941 to October 1942. Well, what was the state of the kind of things in the U.S. in late 1941? The war was about to start, yeah, and the war had been going on. Millions were in conflict in Europe and in Asia since the late 30s. The U.S. by 1939, 1940 was mobilizing, and getting building materials, prime building materials, was not all that easy. So when they got this building built, you see they got all the glass, but some of the lumber apparently wasn't sufficiently dry. So in the first year that it was up, the house was finished sometime in September. They started monitoring the middle of October. In the course even of that first winter, cracks developed, cracks that you could see through. Now, why someone didn't go there with a caulk gun perplexes me, but they also reported that it overheated. And when Hugh or Minna Duncan would say it's overheating, they'd call up Fred and he'd say, "Open a window." Of course, the building is built. I mean, he can't. Well, yes, he can deal with some things, but the lag of this massive radiant floor was not enough. It would heat up, but it wouldn't heat fast enough, and the furnace would be on until the sun. The furnace is on. It's a below zero February day in Flossmoor in the Chicago area. That it freezes overnight. It gets down to below zero. So the furnace is on to heat the house, but then the sun breaks out of the east and starts flooding the inside with light. The furnace goes off, but the floor is already warm. and then it warms and stays too warm. Things weren't balanced. Things weren't quite worked out, but these were in the context. Oh, you can, I've forgotten about this. You can even see the anemometer up here on the top of the roof. See that? There's the anemometer. Testing in action. So the Duncan House they learned a lot from, and it made in 1943 it made quite a nice splash in Architectural Forum. The editor Henry Wright wrote a very nice 3-page spread with photos, but also analyzed the IIT report, which was both complimentary in saying it did reduce the fuel costs, but was quite frank about some of the construction problems and some of the performance issues. I mean, one reason you run a test on a house is you don't know how it's going to perform. You can do this is an interesting thing about back to the Keck papers in Madison, both for this house, the Duncan house, and the previous one, the Sloan house. They did, apparently it's Fred's younger brother Bill, did calculations of heat gain and heat loss, but they did them after the buildings were built. So in some sense, they were designing these. Fred said once, at this stage, it was kind of like 50% glass. 50% of floor space is glass. Because that was kind of this, yeah, I know. Isaac shakes and says, wow. You didn't say wow, but your body language did. But they were learning. And lots of other people too. I mean, I'm taking you through a few peaks, partly because what I'm able to research. Some of the books I'll mention at the end of the talk, where scholars have written in greater detail and filled in a lot of other important people contributing. On the Duncan house, I think it was double pane. It was thermal pane. The thermal pane window has its own little interesting history. It came out in the mid-30s, but the seal was lousy. They fogged up. They filled with moisture. So Libby Owens Ford, with quite an investment in this, paid the Carnegie Institute to not only test them, but to develop a solid seal, which they did over the course of about a year, 18 months, which would be impermeable to moisture. And then it got back on the market. It had to prove itself, but by this time the thermal pane was getting around, and it wasn't failing that often. But I think still, at this era, Fred was getting a 5-year replacement, full cost and labor guarantee from Libby. But it's partly not just Fred, but other builders had been burned the first time the thermal pane came out. So they're overheating, right? So Fred's in this position of how much sunlight can I really endure, and what is going to be best for the comfort of these homes. So that it's kind of a he's learning, but it's also kind of a quandary. He a little bit later, reflecting, he said, well, I would vary between like 30 and 40% glass. That's still quite a bit. Speaking of eagles, 43 years ago today, Apollo 11 astronauts were transiting between the Earth and Moon. In case you're interested. Now the interlude. Where did passive enter language usage? Well, I asked John Perlin this, and he pointed out to me that in 1973, some builders were sitting around in a home that one of them had just recently completed. They were thinking of it as like a thermos bottle. It's like really well sealed. But what are we going to call this? And one of them said, well, in mechanical engineering, we call systems that use pumps or fans active. So I guess this might be a passive solar design. So 1973 is when that term, now you see there's 2 words here, passive and solar. Those really had remained glued together for at least a decade or two, as we'll see a few examples of. Chapter 2, the University of Illinois Small Homes Council, Building Research Council. 1976, Something else dramatic had happened in the world just a couple of years before that affected energy use and interest in energy use. Um, so some of you are old enough to remember that? Yeah. So instead of lines of people lined up for a bread line, as in 1933, in 1973 and 4, it was cars lined up because gas stations all over the U.S., places in Europe, places in Japan, were, instead of getting 10,000 gallons of regular gas, they'd get 2,000. And yeah, part of the response from the University of Illinois, and I've picked out the names of some of the people involved in this. There are a few others, but in 1976, the University of Illinois Small Homes Council published this council notes. It's 8 pages long. It's on the locale house. It's got some interesting design features we're going to talk about, and it predicted 66% energy savings over standard 1976 construction. Two of the principles in this, and I did a little bit of work with these fellows back in the early 80s, Wayne Schick and Sechi Kanzo. Sechi had been at the U of I working in architecture and engineering since the 1920s. I think he had already retired by the early 70s, but kept the emeritus and kept contributing. Wayne had been teaching architecture and drafting and other things at the University of Illinois since shortly after World War II. So he was still more centrally involved in their publications, but Sechi, in his kind of long, technical, beautifully written biography, credits Wayne with being the real, not only the motive force, but the brainchild behind the locale house and these design features I'm going to talk about. But the University of Illinois had been in this for a long time. 1942, World War II, again, millions are dying around the world, or millions are fighting, and thousands are dying around the world. In response to not only the Depression, but then the coming of the war, the University of Illinois, this is before the Small Homes Council was formed, which was 1944 or 45, the Engineering Experiment Station published this bulletin, this booklet, and Save Fuel for Victory. It was it was directed a little bit to builders, but mostly to homeowners. Put up storm windows, use weather stripping, insulate, have an efficient furnace. And it included sections by none other than Sechi Kanzo on home insulation, 1942. Look at this, solar, 1945, the University of Illinois. This is by now the Small Homes Council has been formed. This is one of their first publications. Now, look at the picture of this house. Does this look familiar to you? That's what? Well, no, that's the it's a kind of an unusual angle, but this is another Keck house. It's one done a couple of years later, but it's right in that style. It's right in that style. You see the massive south glass. You see the characteristic overhang for summer shading. And in it, you have right out of Keck, right out of Architectural Forum, the same shade diagram. And there's Mina Duncan sitting there reading her magazine with her back to us. Or maybe that's Hugh. He's come in out of the cold. He's tired of shoveling snow. This didn't appear in the University of Illinois publication, but it was published in mass circulation newspapers. It was a syndicated cartoon, and this is kind of the take on some of the perplexities of solar homes in the mid 1940s. Solar homes continued to be built. They continued to be popularized in Coronet magazine, in Reader's Digest, in House Beautiful. Solar became very current, and then it didn't. then it drifted a little bit. People weren't building solar homes. Fred Keck. Now, I mean, Fred Keck's an architect. He's got a style. He's got, again, I'm picking on Fred because he's a key part of the story here, but you can look at other architects that had picked up solar, following their own research, their own experimentation, as well as things they read in magazines, talked about it at conferences. But it didn't take off besides this kind of boomlet. Fred himself, you know, as a practicing architect, the client has a lot to say, right, about your design. And if they didn't want a solar house, they didn't want windows on that side. Well, look, the site is here. The lake is on the north. I want windows on the north. Well, you know, that's just one example. So back to 1976, back to the Small Homes Council. Let's look at some of the things that were some of the key features of this locale house. And you see locale here in the title. It's you know, it's is this a place where people go to get to diet, to lose weight? No, it's supposed to low calories, low BTUs. It's supposed to be low energy use. So they published these lovely goldenrod colored illustrated diagrams. Here's the wall section with triple glazed windows now in 1976, and the top section, R38 attic insulation, a vapor barrier, and you see the roof overhang for solar control right out of the Keck style diagrams of 1940, 1941, 1945. The details of the double wall. Now this, in being asked about it, this is what Wayne thought was the real key to the innovation, was these double walls, where you had a double wall, you could get up to R33 insulation, the vapor barrier, and by having offset studs on 24-inch centers, you would reduce some of the heat conduction. Now, I'm not going to get into this today, but there were the famous Legere house. A lot of Canadians, especially around Saskatchewan, were really looking carefully into thermal bridges and how unexpectedly you would lose massive amounts of heat by just having a warm surface in contact with a cold surface, even though you looked like you had, look at that, R33 insulation. How's heat going to get through that? Well, okay. But that's ahead of the story a little bit. Then the floor insulation, where you put it below the pipes and ducts and have R10 inside the foundation wall. You know, there were, you see a little bit of fine print here. This was one key publication, but they came out with circulars every couple of weeks. Now, I mean, it was on a vast range of small homes issues, but they had one on crawl spaces. They had one on basements. They had one on storm windows. Yeah, they were doing a lot of things. So here's the variations on the plot plan. So look at these little goldenrod highlights here. What do you think that indicates on all these? Here's a street in Champaign or Springfield or Flossmoor or Oak Park. So what is that? What are those orange highlights, goldenrod highlights? What do they point to? They point south. They point to solar gain. Yeah, that was still a big part of this. They've got the massive, much more massive insulation than they say is the standard of the time. Another odd thing about this is that they published the locale house in 1976 based on 2 years of computer simulations. They went to the feds to try to get money to build this, I guess from very early on. They were dealing with a great reservoir of building science knowledge and knowing about building performance. The U of I, Champaign-Urbana, had been building test residences, and I don't mean a little, 8 by 8 foot module with a little, hip roof on it. 6-8 room houses that people lived in since the mid-20s. Have been testing insulation, different types of heating system. They tried cooling it with ice for a couple of summers with big blower fans. I mean, they had at this period, 1976, they had built up a tremendous reservoir of test knowledge about how buildings performed in Midwest weather, but they couldn't get the money to build it, to build an actual test house. And you see here again, there's still quite an interest in solar gain here. There's the diagram again. They've added April 21st and August 21st. That's kind of a, that's some crafty draftsman saying, I like it better with 4 lines. What the heck. So, Mark thankfully rescued me by helping me out with some heating load calculations of the passive house standard. In their published, again, this is a speculation about how this building would perform with X amount of insulation, with types of siding, with a direct gain through a triple glazed window. The heating load was 14.5 kilo BTUs per square foot per year for 1,568 square foot house. Mark ran the calculations on Passive House Alliance US standards, and it's 475 for the heating load. Significant difference. But the cooling load, interestingly, on the bottom line here, is 5.9 versus 4.75. It's pretty close, yeah. Right. Now, I don't know if he's online today, but Mike McCulley, who was already an experienced builder, and by this time, I think the late 70s, had enrolled as a student at the U of I. New Schick, new Conso, new Rudy Jones, new Harris. Well, he was a builder, so he built one of these houses on spec. Now, he did get some test money through the state of Illinois and I think through the feds. Maybe it was federal money channeled through the states. And they monitored a locale house built more or less to the specifications of the computer simulation. And here were the results. The fiberglass and foam walls performed well. The cellulose ceiling insulation underperformed. There was settling and high measured conductivity. The natural gas furnace grossly underperformed in a steady state and worse in transient conditions. It wasn't a good match between need and load, between load and the furnace itself. The duct work in unheated spaces was problematic. There was need for reliable ventilation strategies. We're going to get more about that in the next section. And the passive orientation, overheating. I don't know. Yeah, sorry about that from before. Mark asked about were there air tightness measures. I'm not aware of them, but I'm having asked that question, I have to look into it more carefully, or maybe Mike can tell us. Yeah, it's a very good question. The issue is in the dialogue at that point, whether or not they specified it. I know that they talked about vapor barriers and they talked about tightness, but using that term in the 2012 context, I don't know how much it would shift to what their thoughts were in the mid to late 70s. The Saskatchewan group was really they were great leaders in this area. I don't have time to cover it today. There were a lot of experiments in the late 70s and early 80s around solar. This wasn't a residence. Not even the little Volkswagen Carmen Ghia was a residence. But passive solar, passive house was getting into the mass market. This is a mass market book written by the Hawkreed Group and my friends Rodney and Sidney Wright. And down here, tiny little bit of the introduction is none other than Bill Keck, who with his brother helped design even the House of Tomorrow in 1933. And here's Bill Keck in 1980 writing the introduction, because he was still keeping on. There was a super insulated house book with a double envelope. Bill Shercliffe After some years working on the Manhattan Project in the 1940s, in the early 1970s, one of his responses to the OPEC oil embargo, the shortages, the expenses, was to do a handful of really interesting survey books on who was building what in solar around the US and Canada and in France and in England and in Germany, and then putting them into interesting compilation books and mailing them out basically for the cost of printing and postage. Here was one of his mass market books, which had a similar approach. He didn't try to, he put in nice disclaimers at the beginning saying, I've communicated with these builders or designers, but you should not, you should be cautious about building to these designs without your own authentication. Part 3, NCAT, the National Center for Appropriate Technology in Butte, Montana. I put a list of some of the people on the technical staff there. NCAT was an interesting hybrid. I'm checking the time here. NCAT was an interesting hybrid in that, on the one hand, it wanted to be like a national lab, like Lawrence Berkeley or Sandia or Brookhaven, because it hired some very brainy people to look at energy problems. The other part of the hybrid is that it didn't grow out of a technical society or a university. It grew out of the federal anti-poverty program. Because some of these people who were waiting in the gas lines in the mid-70s were also facing triple, quadrupled energy costs. And there were very real situations for people of, do I pay my utility bill or do I buy groceries? Things were dire for people living in tight circumstances, and NCAT had this technical staff in Butte. It had an outreach staff. I happened to work for the outreach staff for 3 years, based right here in the Midwest. It also had a grants staff where they would give out small grants. But the anti-poverty program started by LBJ still had some life in it, and there were community action agencies spread out in 3/4, 4/5 of the counties all across the country, and NCAT was trying to do outreach and education and technical support as they were trying to meet the home insulation and home energy saving needs of low-income people organized in these community institutions. NCAT did some very interesting research. They did build some test buildings, and they also corresponded with the people in Saskatchewan, with the people at the Small Homes Council. I don't know if they ever got in touch with Fred Keck. So across the top, super insulation, infiltration control, and heat recovery ventilation for housing. Super insulation, the hallmark is it's cheaper to conserve heat than to supply new sources of heat. Now here was their schematic of the past, present, and future. Now on the left, when I see this 1960s as single pane, I think, well, what no storm window? Come on, that's not, you're not being completely fair here. But the thing I think they were really focused on was the amount of insulation that was being increased. The standards R11, R38, and then speculating to 19 blankety blank. R values? Oh, R values and U values are the same. I don't know where it was originated, but I know that in Tony Denzer might be able to supply this, or someone else, but I know that in Fred's calculations, they were calculating insulation by R value and heat loss through windows by U value. Yeah, yeah. That they were based in Butte. The NCAT was based in Butte. A lot of its the folks used standards from that climate. But on the other hand, there was a national network. There were all kinds of institutions, including the big research labs, who were getting money and getting very interested in this. The Solar Energy Research Institute, I think it was the first funding was in '77, and it may have opened in '78 or '79. They were quite a player in this too, but more a little bit later. So that the standards for wall, 3 fiberglass bats, R11, R19, R11, stacked up like that. The foundation insulation exterior, R20 to R30, pretty substantial. But then when you talk about the northern Rocky Mountains, that's what, 75, 8,000 degree days. That's a rigorous climate. The next, one of the other key publications, filtration control, the air vapor barrier. They said the conventional practice depends on air leaks to get adequate ventilation. You want to have air changes, but this is one of the trade-offs about a real tight house. The continuous air vapor barrier, though, is necessary for effective super insulation, and HRV systems would provide interior air quality and energy efficiency. I draw your attention to this little figure of the guy in the upper left-hand corner. Here's one of the NCAT trainees with his cock gun. You know, he's got a two-tone baseball cap and hair down over his neck, and he's wearing a sweatshirt, and he's got his cock gun. And I heard just this morning from a friend of mine, Dan Hagan, that this was called the invisible hose method, because for untrained weatherization crews, as they were being trained, one of the tools, the insights that the trainer had was, okay, you've got this crack, and imagine you've got an invisible hose, no, an imaginary hose, sorry, an imaginary hose, and you're squeezing the trigger and you're filling the caulk. It's like you're filling this crack with your imaginary hose. Another footnote. And then the third key publication here, also from 1984, HRVs, heat recovery ventilation. Their assessment was there's a lack of system control technology, there's a lack of standard testing, a lack of agreement on indoor air quality standards, and a lack of consumer information. Which of these 4 still hold true today? So the air quality standards, let's say there's a general understanding, an agreement on that. The other 3, there are a lot of claims, there are a lot of systems, there's a lot of good work, but standards, consumer information. So furthermore, just a couple of things to wrap up in the last minute or two. Questions, of course, are still, the floor is open, we're welcome. So what if in 1984, one of these caulkers got into a time machine and went back to 1941 and caulked the cracks in that Duncan house? Imagine how that IIT test would have been different. Now, 2 books that I want to recommend: Solar House, Pioneering Sustainable Design by Anthony Denzer, out from Rizzoli in just a few months, and then Let It Shine. It says Pioneering Sustainable Design. He's basically dealing with 4 or 5 decades in the middle of the 20th century. That's the domain he's chosen. By contrast, 6,000 years, the 6,000-year story of solar energy. Let It Shine. This is John Perlin. I don't know if he has a publication date yet, but it's coming.
I've ended with this slide of Fred and Bill Keck, the two brothers. At the end of his life, reflecting on the state of technology and buildings, Fred said, "Nothing is better in a house than fresh air." That's what you want, natural fresh air. That's the goal. That's what you try to have. Um, but in 1933, designing the house of tomorrow, all the windows were sealed. The air conditioning, the manufactured, the controlled air was, by his own thinking, the highest standard. But things change over time. And speaking of time, we're about out of it. But for those of you hanging on, if you want to post a question or two, or anybody here in Heffley?
Well, thank you, Jim. Um, Compliments are coming in already on the presentation. I want to also just scroll through our sponsors again, because I don't believe my screen was visible earlier. So again, a note about early bird registration coming to a close. It'll be July 24th. So hurry and get your registration in for the conference. And then thank you again to our sponsors, Lumen Catch, Zola Windows, Chemlink, Ultimate Air, Prosoco, Mitsubishi Electric, Intus Windows, and Certainteed. And of course, our hosts tonight here in Chicago, the Hyfala Company, makers of great architectural hardware. So thanks, everybody. We'll have a recording of Jim's presentation on the members-only area within a week. And you're welcome to email myself at info@fayes.org. If you have any questions, I'll put you in touch with Jim.
Could you mention one more thing?
Oh, I'm going to mention one more thing.
Yeah,
hold on. Okay.
Well, you could mention that the Passive House Alliance is working with some of these institutions to get some of their publications online.
That's right. Jim brings up a good point. Through Jim's efforts, we are trying to get some of the older publications that Jim shared with you and other documents that he's discovered through his research into the vaults of these various places. And we're hoping to have an archive library on the FAYES members only area to really preserve these things for everyone's use and information and enjoyment. All right, signing off here from Chicago. Thanks, everybody.